Okay, I'll stand back. This is an interesting evening. I think many of you are from the Congress we're hosting, so you know about it, but some of you don't, that every 4 years all the aquariums in the world get together for an international congress, and it is this week in Vancouver. Vancouver Aquarium Marine Science Centre is hosting. And as part of that congress, we, as hosts, got to help set the program. And one of the topics that's being talked about a lot at the Congress is, okay, we're kind of used to, many aquariums are used to the roles they play in their community. And there's a lot of talk about conservation programs and education programs. There's also a lot of talk about the roles aquariums play in connecting or engaging with their visitors. Because it doesn't matter if you're a nonprofit aquarium, a government aquarium, a for-profit aquarium, we all have visitors. And that gives us all the opportunity to engage our visitors in interest and curiosity and awareness. So to help that along, we put together an august list of keynote speakers to give these delegates a kind of an overview of what's going on in the aquasphere, freshwater and saltwater, worldwide. And so we thought it would be a crime to have all these world experts in Vancouver and not let them talk to some people beyond just conference delegates. And so that's what we're doing tonight. We're going to give each speaker about 5 to 7 minutes, which is a condensed version of their 45-minute talks at the Congress. When they've all spoken, we'll invite them all up to the table, and we'll do a bit of a Q&A. So we've already been asked to turn off electric devices. The Twitter handle is on the screen. Do feel free to tweet. We're going to start with Dr. Greg Flato. He's a senior scientist with Environment and Climate Change Canada's Canadian Centre for Climate Modelling and Analysis in Victoria. He has extensive experience in global climate model development and application. He serves as the co-chair of the World Climate Research Program's Climate and Cryosphere Core Project. So, where'd he go? There he is. Okay.
Alrighty. Excuse me. This is a dangerous microphone. All right, so I gave this plenary talk this morning. I felt a bit like a fish out of water there because I'm not a fish guy, and now I'm standing here in an aquarium, and I don't know anything about fish either. And so I was trying to think of what, in 5 minutes, what can I talk about that's going to be useful or relevant? And the thing I do know a little bit about is climate, so I thought I'd talk a little bit about climate change and what the role that the ocean plays and why the ocean has an important consequence on things that are connected to mitigation actions, that is why we need to reduce carbon dioxide emissions in order to stabilize temperature. So I thought that's what I would try to talk about. I got 3 slides. They all have some, science content, but I'll just try to talk about them fairly simply. As most of you know, the human activities, one of the things that we do is we burn fossil fuel, and the byproduct of burning fossil fuel is putting carbon dioxide and other greenhouse gases into the atmosphere. Now putting those greenhouse gases into the atmosphere alters the radiative properties of the atmosphere, and that has important consequences, and these are consequences that have been known for a very long time. The temperature of the Earth is determined by a balance between the incoming shortwave radiation, that is the visible sunlight that you see, and outgoing long-wave radiation. That's the infrared radiation that you feel like as heat. That balance determines the temperature of the planet. And greenhouse gases act to moderate how easily it is that the planet can radiate infrared radiation to space. So when you change the amount of greenhouse gases in the atmosphere, you make it a little harder to radiate that long-wave radiation to space. So the only way that the climate system can respond is to increase its temperature a little bit so it can radiate more. So that altering of the energy balance changes the amount of energy that is kept in the climate system. So here's the 2 slides, or the 2 pictures here. I better start talking and pointing rather than talking. So this just shows you emissions from various sources. So the emissions are shown up above. So this is the gray band is emissions over time. This is starting at kind of the dawn of industrialization in 1750 up to the present. So the gray band is emissions that are due to fossil fuel and cement production. Those are two big sources of greenhouse gases. The yellow is emissions that are due to land use change. That is when you change the forests into agricultural land, you disturb the soil, you put some carbon into the atmosphere. That's been relatively stable, but greenhouse gases from fossil fuels and cement are increasing. Then at the bottom, this is where that carbon is being taken up. So some of that carbon is being taken up by, I have to use my glasses because I can't see over there, is being taken up by land, that's the green stuff. Some of it is being taken up by the ocean, that's this blue stuff. The dark blue stuff, and some of it remains in the atmosphere, and we observe that as increasing concentrations of carbon dioxide in the atmosphere. Okay, so that's where the carbon is going. The ocean is taking up some of that carbon. It's taking up roughly a quarter of the carbon that we emit. So a quarter of the carbon, that's not a very big number, but it's taking up a huge amount of the energy. That energy imbalance I talked about 90% of that imbalance in energy is taken up by the ocean, and that's what this figure over here shows. This is the energy uptake in the ocean from about 1970 onward, and almost all of it is in the ocean. The light blue is the upper ocean, the dark blue is the deep ocean, and the atmosphere is this little tiny thing here. That's the energy that's being stored up in the atmosphere that we perceive as increasing temperature. It's a very small amount. All right, so what does the ocean do? It takes up energy, it takes up carbon. When it takes up carbon, it changes the chemistry of the ocean. It lowers the pH, that is, it makes the ocean a bit more acidic, and one can observe that. This is observed ocean pH that's declining here. The other thing it does, it takes up all of this heat. When it takes up heat, the ocean warms up, and when it warms up, like most things, when they warm, they expand. So in this room, as it warms up, we're going to expand, and pretty soon people will be falling out the doors. But as the ocean warms up, it expands, and the only place it can expand is to rise. So sea level, a lot of what has been observed in terms of sea level rise is attributable to just the ocean warming up. In addition, as the climate warms, a lot of that ice is in glaciers and ice sheets is melting and contributing water, which is also causing sea level to rise. All right, the ocean, the last slide that I want to talk about is that the ocean also imparts very long time scales into the climate system, because that heat and carbon that it takes up, it puts into the deep ocean where it lasts for a very long time. That is, the time scales for deep ocean circulation are many centuries, and so heat and carbon that's taken up at the surface gets down into the deep ocean and doesn't reemerge again for many centuries. That puts a very long time scale into the climate system. And one of the ramifications of that long time scale is that if you turned off emissions completely, stopped them altogether, you would think that temperatures would drop right back down to where they were. In fact, they don't. They stay stable. And they stay stable for many centuries, because as the carbon is slowly being sucked out of the atmosphere by the ocean is also slowly adjusting to this warm temperature and is warming back up. The two cancel each other out almost perfectly, so that in the end, when you stop emitting, the temperature basically stays stable. And it turns out that coincidentally, these things just balance out such that the cumulative amount of carbon that you put into the atmosphere is directly related to the temperature at which the climate stabilizes. And that's what's shown here, if I can only find the right button. So this is cumulative total human CO2 emissions, and this is temperature change. And it's very linearly related, and it doesn't matter whether you put it in quickly, whether you put it in slowly, whether you put it in over a long time or over a short time. It's linearly related. And the bottom line is, if you want to keep temperature change below some value, like 2 degrees, you can read off how much total carbon you can put into the atmosphere. And that gives you a budget for the carbon that you can put into the atmosphere. And that ultimately is the thing that all of the policy discussions about climate mitigation are based on, is reducing emissions to stabilize temperature. And the reason that we can read it off from a graph like this is because the ocean is so slow. Thank you.
So I guarantee these things will all be knit together when we get done. Next up is James Guest, who's a research fellow at the University of Hawaii. His research focuses on coral reefs in Southeast Asia and Micronesia, and the ecological processes that affect recovery and persistence of reef communities. I think we all, even though we don't think about BC as having coral reefs, we all know how important coral reefs are to the world's oceans. James is also a science advisor for Seacorps International, a coral reef conservation charity that works closely with public aquariums. James?
Thank you. Okay, thank you. I've been diving on reefs for about 25 years and was fascinated the first time I did a scuba dive on a reef by the diversity, the complexity, the color, and just what amazing ecosystems they are. And the more I've studied them, the more I've sort of fallen in love with them. They're some of the biggest structures built by living organisms on Earth. They're they're considered the sort of one of the pinnacles of diversity, forests, tropical forests being the other one. But importantly, they provide income, food for millions and millions of people living in tropical countries. And some of the recent valuations of coral reefs have suggested that they're worth something like $18 trillion a year, because they provide all these ecosystem services like food, tourism, coastal defense, things that would cost us a huge amount of money to do if we had to build them ourselves. So it's incredibly worrying that these systems are some of the most threatened on the planet at the moment. And I often sort of shift between optimism and despair when I read papers and the news about what's happening to reefs. So at the end of last year, the Paris climate deal was signed, and that was an enormously positive thing for reefs, because reefs are incredibly vulnerable to high temperatures and acidification. But then only, I think, a week later, I looked at the Guardian website, as I do in the morning, and read about reefs in the South China Sea that were being completely destroyed wholesale and being built over to build military bases and being utterly destroyed without anybody doing any mitigation whatsoever. Again, I felt a ping of optimism and hope when President Obama announced that the Northwest Hawaiian Islands, part of the Northwestern Hawaiian Islands, would become one of the biggest the biggest marine sanctuary in the world. And that was fantastic. But then at the same time this year, reefs in Australia, the Great Barrier Reef, one of the most well-managed coral reef systems in the world, is suffering its most severe coral bleaching event. So that suggests that even reefs that are protected are still incredibly vulnerable to climate change disturbances. So what's sort of happening to these reefs? Are there any signs of hope? Are there some reefs that are thriving and doing much better than others? Well, this is data from the Caribbean. This is the Global Coral Reef Monitoring Network, which is a group that look at long-term data. These are graphs showing coral cover. This is one of the measures that we have of coral reef health. We look at how much coral there is on the bottom. And of course, you can see that over the last sort of 40 years or so, most reefs have declined as expected. We know this from overfishing, hurricanes, bleaching disturbances, and we have these sort of hockey stick type graphs and declines. But then there are some reefs that have still stayed stable or even increased in coral cover despite all these disturbances. So this gives us some hope that there are some incredibly resilient reefs. And remarkably, there are some places in the world which, despite everything that we throw at them, the reefs still seem to be fairly resilient and do quite well. So I worked in Singapore for a long time and dived on all of the reefs around Singapore, and these are some of the most disturbed reefs anywhere in the world. Singapore has 5 million people on a tiny island. It has one of the busiest shipping ports in the world, with 140,000 container ships coming in and out every year. The entire southern coast where the coral reefs exist have been completely reclaimed and are modified. There's no natural coastline at all. But yet, just a few tens of kilometers offshore, 5-10 kilometers offshore, there are these really diverse coral reefs which are remarkable. And we see fish, sharks, turtles, and all these sort of incredible organisms that you wouldn't expect to see in this system, which suggests that some reefs are incredibly tough and much more resilient than we sometimes give them credit for. The other thing that gives me some hope, and this is my last slide, is that scientists who work on coral reefs now have really shifted from warning people and sounding warning bells. For about 30 or 40 years, scientists have been saying reefs are being degraded, human activities are degrading reefs, and people have been saying that. And this degradation is happening, and now people are really shifting towards solution-driven science. And at the last big Coral Reef Congress, there was an enormous shift in people trying to come up with ways that we can counter the effects from climate change, because we can do all the local management and protection that we want, but those systems are still going to be incredibly vulnerable to increased temperatures. So one of the ways, and this is not the only one, but this is an area that I've worked in and I'm fascinated by, is whether we can actively intervene to restore coral reefs. And it's an incredible last resort, and it's unfortunate that we've got to this stage, but we have to sort of develop these methods now. So one of the things that we're doing is rearing corals in tanks. We get them to spawn. They produce millions and millions of propagules. We can rear them, and in nursery conditions in the sea, we can get many of them to survive, when in nature they wouldn't. And we've been planting them out onto the reefs. And the big next stage for us is to see if we can start to select for tougher corals. Can we breed corals that are particularly resilient to climate change disturbances like increased temperature and acidification? And that's a really exciting a new area of science. And it gives me some hope for the future if we can find solutions that allow corals to become even sort of tougher and to deal with some of the things that we're throwing at them at the moment. Thank you.
Thank you, James. Dr. William Chung is an associate professor at the Institute for Oceans and Fisheries at UBC and science director for the Nippon Foundation UBC Nereus program. His main research areas include understanding the responses and vulnerabilities of marine ecosystems and fisheries to global change, and examining the trade-offs in managing and conserving living marine resources.
Thank you very much. Hi, good evening. So I want to start off with a couple of slides showing the current status of global fisheries under a number of major global drivers of changes that are related to human activities. The first slide I want to show is this figure. I think this is one of the best figures that encapsures a lot of different elements about the oceans and fisheries. First of all, this is a figure showing the global productions of fisheries catch from the ocean. It highlights that the ocean is very important to us in terms of, through fisheries. It's providing us with fisheries catches, which support lots of livelihood, particularly people who are dependent on coastal resources, such as fishing communities, and the industry that are dependent on fisheries and seafood. It's also generate revenues and provide nutrients for lots of people that are very important for their health. However, this figure also shows that there are some major issues that are happening in our fisheries. First of all, you will notice that there are these two colors that differentiates the reported catch and the unreported catch. The reported catch are those that are recorded officially by, for example, by the government or by the United Nations Food and Agriculture Organization. But then our colleagues, my colleagues, Daniel Pauly and his team, and including some of the researchers that are actually in the audience here, did a lot of work trying to see whether the official catch are accurate or not. And they find that it is not. Particularly, there seems to be a major underreporting of fisheries catch that in reality, we are catching much more from the oceans relative to what's reported. And actually, we may be catching around 130 million tons per year in the 1990s. Thirdly, one thing that is striking is that since the 1990s, with the re-estimated catch, fisheries productions is actually declining. That's not a very good sign, particularly if we look at the changes in fishing effort, in which we find that fishing effort, which is a measure of the ability of us to catch fish, increased substantially since the 1950s and continues until recent years. It also means that even though we try harder and harder to catch fish, we cannot catch more fish, but fisheries production actually decrease. For most of us fisheries scientists, this is a sign of overexploitation. And in fact, recent estimates suggested that up to 60% of global fish stocks are overexploited. And the question is, then how can we manage these fish stocks in order to rebuild the stocks and recover the potential productivities of the ocean? The second major drivers of changes from human activities on the oceans is through climate, something Professor Plateau talked about. The carbon dioxide that we pump into the atmosphere do not stay in the air. A lot of it go to the oceans. And at the same time, the ocean is a really good heat absorber. It absorbs over 90% of heat that are generated. So with more carbon dioxide, more warming in the atmosphere, there are a number of consequences. The ocean's temperature is also changing, and in lots of places it is warming up. Also, with carbon dioxide in the water, it makes the water more acidic too. And there are also areas of the oceans that are becoming less oxygenated. And as you know, organisms need oxygen, so that's not good news for organisms too. And if we put this information, as well as our best understanding of the biology of marine fish and invertebrates, into an analysis, a computer simulation models, just try to determine the potential responses of organisms to climate change and then how that will affect fisheries. We find that changes in the climate and the ocean conditions may have a big impact on marine fisheries and catches. I'm taking an example just outside of our oceans at the British Columbian coast. Particularly in this example, we look at species that are really important for coastal communities, particularly First Nations, who depends on this seafood for their food as well as culture. We find that with business as usual scenarios of CO2 emissions, we can lead to a substantial decrease in potential catch. But the good news is, if we are able to reduce our emissions, we can substantially reduce those impacts too. For example, for salmon, with business as usual, we may be seeing 30% decrease in catch, but then if we are able to go to the low emission scenario, we're able to reduce it down to around 15%. And in fact, the science that we have been doing, some of the science that I just showed you, as well as lots of scientists that are generating the knowledge that try to understand the ocean's responses to human activities and how we can actually better manage the oceans, actually provides really good support of developing global as well as regional ocean policies to ensure sustainability. There are lots of these policy discussions and agreements that are happening. For example, the Paris agreements under for the climate change that set a really good goals for going into a world where we will have a substantial lower warming and lower emissions. We have the Archie biodiversity target that set a really good goals of how we should conserve our biodiversity, such as setting up, say, 10% or at least 10% of the ocean areas for protection. We also have the Sustainable Development Goals, which provide a more comprehensive set of goals that allows us to both conserve the environment, including the oceans, as well as from there trying to ensure other aspects of sustainable development of the society, such as food security, health, and things like that. And in fact, the future of ocean sustainability, ocean conservation and management needs to think much, much broader in the sense that we do not only focus on looking at the oceans per se, because it's not enough. We need to connect it to the bigger society. There are areas that the oceans needs to be managed by actually solving some of the social problems first, before any problems in the oceans can be solved. And at the end, I want to pose that besides these high-level national, regional, and global initiatives, there are lots of things that we can do. And in fact, I think the public is on our side in terms of the ocean. This is a analysis that my colleagues in our program did. What we did is try to look into the Twitter space and try to see what people talk about when they mention about the oceans in Twitter in the last couple of months. What we find is very interesting. We find that whenever people mention about oceans, it usually associates with positive things. Things like joy, trust, anticipations. So it means that when people think about ocean, they think about good thing. So I think this is something that we can actually promote, and particularly connecting with our science of how we can actually manage the oceans to make better managing the fisheries, reducing emissions, providing good adaptations. I think there's a good chance that both this top-level policy as well as bottom-up public-driven actions can actually ensure sustainability of the future oceans. Thank you very much.
Thank you, William. Dr. Peter Ross is Director of the Ocean Pollution Research Program at the Vancouver Aquarium Marine Science Centre. He's worked in marine pollution for over 25 years and has pioneered new techniques to evaluate the effects of persistent pollutants on the health of marine animals. His groundbreaking studies include the health of BC's iconic killer whales, the effects of flame retardants on belugas, the presence of hydrocarbons in sea otters and in their habitat. He's worked on the trends in priority pollutants in harbor seals and on the impacts of currently used pesticides on the health of salmon. He's an international expert in the area of ocean pollution and has published more than 120 scientific articles and book chapters. Peter?
Thank you, John. Thank you, everyone. So I have 5 minutes to tell you what I feel is a pretty complicated subject area. We're hearing a lot about a lot of relevant, interesting, important scientific ideas tonight, and ocean pollution is my challenge. And when I talk about ocean pollution, often what we see at the front page of many newspapers or headlining in the news are oil spills. People think about direct pollution impacts, non-climate related impacts, although certainly related in a direct manner. Catastrophic oil spills and impacts on charismatic creatures. And certainly this is something we're worried about. Oil spills are unacceptable, even for industrial proponents, and they do cause long-lasting damage. But what a lot of us don't realize is that hydrocarbons are leaking from our ships and boats and harbors and running off from city roads, etc., and contaminating local waters and contributing much more in the way of hydrocarbons than some of these catastrophic oil spills. And a bigger challenge yet is to talk to an audience or to start to point society towards other ocean pollution priorities, because we hit 100 million chemicals registered on the international marketplace in 2015. 100 million original distinct chemicals. That's according to the Chemical Abstract Service. Approximately 250,000 of these chemicals are thought to be on the global market. There are estimates ranging from about 100,000, 500,000. So understanding what each and every one of these contaminants might do when it hits the ocean, where it's going to end up, where it's going to accumulate, whether it's going to break down, who it's going to harm, is very, very challenging. And you might be surprised, you might not, to learn that we only study as ecotoxicologists a handful or two of these 100 million or 250,000. So what we tend to do is we focus in on a couple of gold standards like PCBs or DDT or dioxins or mercury. And we tend to study those and use what we learn from some fairly in-depth studies of specific chemicals to predict what might happen with some of these other chemicals. And two of the key drivers that I look for with chemical properties are their persistence and their water solubility. This is really going to dictate whether we're going to find a chemical in the ocean, whether it's going to last in the ocean, whether it's going to dissolve in water, And if it doesn't dissolve in water, it dissolves in fat, which means it binds to particles, sediments out, or gets incorporated in the food web and goes up that food chain. So those are two very key, very simple concepts by which we can simplify a very complicated world of 100 million chemicals. Some of the concerns we have when we look at ocean life or ocean creatures is this last point. The safety of these chemicals is typically carried out, by and large, using laboratory-based studies on the water flea, that's Daphnia magna, and the rainbow trout in lethal concentration testing from anywhere from 24 hours to 30 days, and that's basically it. The rest tends to be modeling and risk assessment and some kind of extrapolation to protect human health, but typically when we have a new chemical on the market, very cursory evaluation for safety, and we certainly don't include or incorporate some of our beloved charismatic creatures in that risk assessment unless there are special dictates. Another number for you. The world's most contaminated marine mammals are right here on our coastline. We have the Biggs killer whales. These are the marine mammal-eating killer whales, top of the food chain, very long-lived. They accumulate contaminants, these persistent contaminants that are water-soluble from their prey. Their prey, 90% of what they eat is 50% of what they eat is harbor seals, so they're very high in the food chain. And then what we're talking about is a mix of different types of persistent organic pollutants, including the notorious PCBs, that together with another couple of threats, noise and disturbance, and reduced abundance of prey, provide direct threats at a conservation level, which has led to Canada and the USA declaring the southern resident killer whales as endangered. So there's another number, and that's a single chemical class. That's one contaminant out of 100 million. This is also a story about the planet we're living on here. We can look at these long-lived killer whales and we can talk about them as sentinel species that are telling us something about the northeastern Pacific Ocean. I believe they are, and they do. They can inform. But it's also important to recognize that these contaminants do not show any respect to international boundaries, hence the importance of international treaties, but also international monitoring program. How many of you are aware that it only takes 5 to 10 days for any of these pollutants released into the atmosphere to move with air masses from Asia to North America? It takes the same amount of time from air pollutants released in North America to reach Europe. And again, it takes the same amount of time for those air pollutants to be released and transported from the industrial heartland of North America to the remote Arctic environment. And what happens then is these contaminants rain out, fall out, and then they can become incorporated into food webs and contaminate food webs up into different species in remote parts of the world. It was this understanding that really was spearheaded by Canadian science the world to adopt the Stockholm Convention, a very, very important piece of treaty. 25,000. When we took a cubic meter of seawater from False Creek, right outside Vancouver, we counted 25,000 particles of plastic in a cubic meter of seawater. And those particles of plastic, you see them here, consist of fibers and fragments, and they're being mistaken by for food by different zooplankton species. They're being ingested. So we have trouble at the bottom of the food chain as well. This is a very important number to me because anytime we talk about coastal pollution, we raise concerns among Aboriginal communities that rely very heavily on seafoods. The average coastal First Nations resident is consuming 15 times more seafood than the average Canadian or the average American. In the Arctic, the Inuit are consuming over 25 times as much seafood as the average Canadian. This means a couple of things. Number one, 15 times as much in the way of pollution exposure that is delivered via seafood, which means there could be potential concerns about health. And secondly, it means it's all the more important to protect marine resources for subsistence-oriented consumer groups like Aboriginal communities along all of our coasts. So that's a very important driver of this kind of science. But I would argue science is an important tool, but it does not stand alone. It has to be combined with the traditional knowledge derived from these communities that help identify food, social, and ceremonial values associated with marine resources. And science is something that we can do when we engage with the public in support of designing effective solutions. So I've tried to take a complex story and hopefully speak to the simplicity in the threat that pollution presents to our world, our ocean world. Thank you.
Thanks, Peter. John Englander is an author, oceanographer, consultant, and one of the world's experts in sea level rise. His broad marine science background, coupled with degrees in geology and economics, allows him to work on the big picture of the climate and oceans and to look ahead to the large-scale financial and social impacts related to sea level rise. For over 30 years, he's been a leader in both the private sector and the nonprofit arena, serving as CEO for such noteworthy organizations as the Cousteau Society and International Seakeepers. He's written a best-selling book called High Tide on Main Street, Rising Sea Level and the Coming Coastal Crisis, that clearly explains the science behind sea level rise, and he's going to give us some insight tonight.
Thank you, John. I take sea level and as a special aspect of climate change in the oceans because, of course, it determines where the shoreline is. And how we think of things, how we perceive it, how we frame things really has not only a logical and an intellectual impact, but an emotional impact. So sometimes what many of us do, I think, here are how do we communicate differently with people? And it starts with something as simple as what's the balance between oceans and land? And there's two ways to look at that number, as it says at the top. It's either 71% or 72% as surface area, but in terms of the biosphere, the oceans are about 98% of the planet, because on average they're 4 kilometers deep, as opposed to a couple of hundred meters from tree canopy or even the bird heights of flying to the soils. So how we perceive things is a challenging, it's not to be smart in terms of being more clever than the next person, but it provokes us to start thinking about the oceans. I did a blog post or a tweet this morning. For the first time, it occurred to me flying back from Greenland last month that the oceans and land are a bit like yin and yang, you know, two contrasting but complementary concepts. And I try to make things super simple because when we communicate to a wider audience, we need to do that. And I hope not only for yourselves, but you go forth tonight and do that. Carbon dioxide, as Dr. Flato talked about, has been rising since it was measured not only in 1958, but we know it's been going up for hundreds of thousands of years over long term. Mimicking a graph he showed, actually, again, that since the last 80 years that carbon dioxide in red is dissolved in the ocean in about the same concentration shown in green, and the reverse of that is pH, or acidity. As carbon dioxide goes up, acidity goes down. It's really very simple. This is a graph that I've produced, and it's available on my website. You can use it. I hope you download it and do something with it. But it's been described as one of the simpler messages to really put climate in context. At the top is carbon dioxide in green, a greenhouse gas. In red is global average temperature, and blue is sea level. And following 400,000 years, 4 ice age cycles, and even those who doubt climate change don't doubt ice ages. We've had ice ages, but most people don't know when the last ice age was. And the last ice age was about 20,000 years ago. What do I need to push here? Well, I guess it does. There we go. So the cold spot was 5 degrees Celsius cooler than now, 9 Fahrenheit. And it turns out that the Earth has had this regular cycle about roughly every 100,000 years. Been going on for 10 times to the left, about 3 or 4 million years. This is just the last 400,000 years. So we can see some detail. So what's really interesting about this, I think, and I hope you think, is that not only do we see that there's a regular period of climate change, as evidenced by temperature, but that as the Earth warms, ice melts, and so seas rise. That makes sense. So the peaks of sea and temperature go together. There's 4 periods here. And it turns out carbon dioxide and temperature go together because of the greenhouse gas effect, as several people have referenced. And that was proven in 1827. It wasn't a new discovery by it's simple physics. And the problem is that, as you see at the upper right, that carbon dioxide is broken out of the normal range of 180 to 280 parts per million, roughly, and it's now at 400 and climbing. And that's the problem, because the temperature is now chasing it, and as temperature warms ice and melts it, sea level is going to rise. It's really a pretty simple correlation. So I think as we try to communicate to bigger audiences, not only to yourselves, but to your colleagues, friends, and whether they believers or doubters, it's interesting to and useful to make it simple. We get that data from ice cores in Greenland and Antarctica. We can get slivers of ice that have bubbles that contain the CO2 percentage and 2 different isotope oxygen measurements that give us relative temperature. But back to sea level, because sea level changes the shoreline. And one of the biggest impacts of climate change is that the ice is going to melt. So sea level has risen 390 feet, 120 meters, since the last ice age. It got to the present level about 5,000 years ago. You all saw this science movie, did you? The Ice Age Part 2, The Meltdown. Well, the 2 miles or 3 kilometers of ice back there, when that melted, sea level rose 120 meters. Makes sense. And sea level this century has risen about 18 to 20 centimeters in the last 160 years, shown there. Pretty steady, getting steeper. But the level of misunderstanding is so profound and counterintuitive to some degree that people think the melting polar ice cap, kind of just shown here, is why sea level is rising. But as many of you probably know, and if you don't, you can run the science experiment at home. Just take a glass with floating ice cubes in it. It can be water, iced tea, scotch, whatever you want to drink. And the ice cubes will be about 10% above the surface, like an iceberg. And when it melts, it won't change the level of liquid. You have to add external ice or water from outside the glass to raise it. And the same thing with the oceans. The problem is that the ice on land, Greenland and Antarctica, have enough ice to raise sea level 7 meters and 56 meters respectively, or 24 feet and 186 feet, a little over 200 feet. Now that hasn't happened in millions of years, but we're working to break the record right now. Greenland, or the North Pole here, shown as an overhead view, is floating sea ice. Canada's to the left, in effect. Greenland is to the 7 o'clock position. Most people forget about the fact that it's not land, that's floating ice. It has no effect on the level of liquid, the oceans, as it melts. But what's happening in Greenland, and I'll flip through some slides very quickly that we took a month ago when we were in Greenland, and the Vancouver Aquarium also ran an expedition there on a ship. I was there by plane with the U.S. Coast Guard. Greenland is melting very quickly. It had been 9 years since I was there, and there's a lot more land and a lot less ice. This is the head of the U.S. Coast Guard, Admiral Zukunft, who I was there with him as his climate expert. But it was very telling. He's looking out at Jakobshavn Glacier. And very few probably know this, but that iceberg off in the distance, you can kind of see right in the middle of the frame here, on that fjord. On the far left, up here, is the calving face where the glacier is calving. And then there's this giant iceberg, which is 10 times underwater, what's showing on surface. And it's going to work its way over the next few months out to the ocean, and it'll get into the shipping lanes. And this is the same place that the iceberg that sank the Titanic emanated from. And here's the head of the U.S. Coast Guard with me. And there's a cruise ship going through the Arctic, Crystal Serenity, as we were there. And you know, the Arctic's opening up. We can do shipping, we can drill for oil, we can do cruise ships. But of course, it's not an ice-free Arctic, it's just less ice. There's going to be more icebergs than ever as these glaciers melt more quickly. This is a very disturbing photo. This is just taken out of an airplane window flying out of Greenland. But it kind of looks like all like ground. But the right 2/3 of this picture is ice. It blends in with the ground, which is getting more exposed, and the ground or gravel or rock, which is being pulverized by thousands of feet of ice that was there, or meters, is now blowing up onto the ice, and it's turning it gray. And when things get darker, they absorb more heat, like painting a white roof house dark gray or black. And that's happening, and we're getting lots of melting. And in Antarctica, even worse, in terms of potential sea level rise. There are 6 glaciers that account for 3 meters of sea level rise there. And our concern is when that will happen. And Dr. Flater and I were talking this afternoon about the problem is the uncertainty. We don't know whether those glaciers are going to slide into the sea this century or next. We really don't. And so from a scientific standpoint, when people say, what do you know will happen? We don't include these, all right? And that's how we get an answer in saying, well, it could be a meter of sea level rise. But if you include just those 6 glaciers, there's another 3 meters. So what do we plan for? So, and these glaciers are being undercut. Now, the Paris Climate Accord, as you've heard about, says we should try and set a target of 2 degrees Celsius of warming. I'm done, I guess. On the current path, we're going to hit 4.5 degrees of warming. The current projections get us to 3.5 degrees of warming Celsius. We have a lot of work to do. I try and conclude with 2 messages. Let's work as hard as possible to reduce the warming through greenhouse gas reductions, and British Columbia is probably the best place in the world in terms of policy on that, in terms of the carbon tax. And 2, let's use the reality that even if the world were 100% solar today, right now, never burned any more fossil fuel, we're still going to get sea level rise. So let's begin adaptation. And where I close the loop with the third part of that is, once people get concerned about losing real estate, property, they get more interested in what can we do to slow the warming. So that's how it all comes full circle. Thank you.
And finally, Julie Packard is the founding executive director of the Monterey Bay Aquarium. Based on a lifelong passion for science and nature, she led the aquarium since its opening in 1984 to become a global force for ocean conservation. She also chairs the board of the Monterey Bay Research, MBARI, Monterey Bay Aquarium Research Institute, a global leader in deep ocean science and technology, and she's engaged with ocean conservation strategies through her work as a trustee of the David and Lucille Packard Foundation.
Thank you, John. I want to start by thanking all of you for being here at this fabulous institution, Vancouver Aquarium. You're so lucky to have this wonderful aquarium here in your city, and really congratulate this institution and the team for all the leadership they provided in terms of pushing the envelope on what a public aquarium can be as a force for science and conservation, which is something that we've tried to do at our institution in Monterey. So I'm here, I guess, to wrap it up with some inspiring messages, and no worries, because that's what I do. That's what I love to do. And I guess just starting quickly with the big picture. I mean, no one mentioned kind of the big wrap-up message, which is the ocean is our life support system. It's our lungs, our pantry, our playground. It's a vast driver of global commerce. It's a storehouse for innovation in terms of solving future needs. And as we know, for too long, it's been out of sight, out of mind. Most of us live on the coast. And of course, for all of us that have the privilege of living on the beautiful coast of North America, as I live in Monterey, California, many of you here get to live here in Vancouver, we're reminded every day of the ocean, but not so for a great deal of the world. So I run an aquarium. I'm here for an aquarium congress. Aquarium leaders are gathered from around the world to talk about aquariums and what we're up to, and most especially what we can do about conservation, what we can do about these issues that we just heard about today. And of course, the main thing that we have going is this: people. We have tens of millions of people that come to our places every year, and we can provide an amazing experience that gets them in the heart. An animal encounter. But we do a lot of thinking and stressing out over, okay, how can we take that to the next step? And what does it really mean? And how can we get people to take action on these critical issues that we were just talking about here today? Well, in Monterey, a little bit about the trajectory of our institution that in Vancouver has done a lot of the same things that we have, and we have an amazing network of aquariums around the world that can pick up this theme and carry on. So, of course, on the coast of California, you find Monterey Bay, and you can see in the lower right-hand side view of the deep canyon in our bay that makes it a very rich ecosystem. This inspired our family and our family foundation to build an aquarium all about Monterey Bay. And of course, hopefully many of you have been to the Monterey Bay Aquarium. Later, that inspired us to create a research institute to study the deep sea based on the amazing canyon that comes into our bay. And then finally, the aquarium to kind of expand our scope to do research on the vast Pacific. And the colored graph you see there are satellite tag tracks of the top predators that use the Pacific as their foraging ground. So what does it all add up to? In Monterey, we really have an amazing success story and a story of resilience, how an ocean ecosystem that was once, to be honest, a tale of fisheries collapse. Hopefully many of you are familiar with Cannery Row and the tale that Steinbeck wrote about, which really is one of history's most epic stories about a combination of overfishing and not being attentive to trends that were happening in the ocean that were driving down the fish stocks at the same time. Through the action of people, again, armed with science, the situation was turned around over time. Today, the southern sea otter is about to be taken off the threatened species list. We have sardines back in the bay, although they're now kind of being fished again and a little on their way out. Never mind that, mainly because the ocean is changing. And will we do the right thing is a good question. We also, of course, have myriad other amazing animals that are now thriving in this area that is a national marine sanctuary and also part of a network of marine protected areas. Protected areas let the ocean have a rest. They enable us to provide areas where the ocean can be resilient in the face of these huge challenges and changes that we just heard about earlier today. So this image just kind of wrapping up and reminding us of the dreaded things going on out there in our oceans every day, the overfishing, the impacts of climate change, and pollution in all its forms. Here we're looking at trash. Obviously, the persistent organic pollutants that Peter talked about are an even larger problem. And the news seems daunting, and the question is, what can we, and in particular, what can our aquariums do about it? Well, aquariums over time, and especially in Monterey, we've kind of led the way on this. We have some unique roles, and we're really working on impact, I think, in an area that can, in many areas that can really apply wherever you are. I mean, the first thing is really the idea of taking care of our place, of our own backyard, like you're doing here along your coast. We've done in Monterey Bay, creating protected areas for resilience, attending to local land use planning, so you're not, overdeveloping your wetlands and creating pollution issues with your storm drain systems. All of those are things that you can get involved with at your local city hall or in your provincial government, wherever you are, because you're the only ones that can make that happen. These things do not happen unless people mobilize and ask their leaders for them. Our aquariums also, of course, we have animals. We're all about animals. And over time, we've been able to do some amazing work with these animals. It's really a privilege to be able to work with them, not only in our aquariums for educational purposes, but also in the wild. In Monterey, we've been super involved with rescue and care and release of orphan sea otter pups. We have a small population in California. It was thought to be hunted to extinction. It's rebounded from a tiny population of 50 animals. I mean, what an inspiring story. And now it's not out of the woods, but rescuing and rehabilitating and caring for every pup that we can to get them back in the population is really making a difference. In fact, a study we just got showed that the otters that we put back into our region have contributed a big piece of the population growth in a certain area, a slough where all the otters hang out. Of course, otters aren't just a pretty face, or a cute face, not pretty. They are the cutest animal, perhaps, ever. But they also are working animals. They're working every day to maintain the ecosystem, and we're learning more and more about the role of animals like sea otters and everything else we see along our coastline. Of course, our coastal ecosystems are the most rich areas. They're the fishing grounds. They're where it's all going on, and also all going on for the human interface. And then finally, many of us, and Vancouver Aquarium has been a leader in this too, are taking some incredible action around stemming the whole global overfishing situation. The way we fish and farm seafood is creating huge issues, not only for the fish, but as important in terms of habitat damage and alteration of the ecosystems that essentially enable life to exist here on Earth, including ours. So the sustainable seafood movement, which of course Vancouver Aquarium is part of this, it's so exciting. I'm really pumped up about it, and I thank all of you who've been part of it. I'll say another word about it in a moment. On the wildlife front, though, just an example of how we've been able to, at our aquarium, and you all, sounds like you're doing this too in terms of your work with orcas, doing the science is great, and aquariums can support that. If any of you are donors to this aquarium, I hope you will support that. But then the important thing is to take that science and put it into policy action in the water on behalf of those animals. In Monterey, we were the first to keep a, sorry, this slide didn't transfer onto this template. It looks a little weird, but the main issue, the main point is we were able to keep a white shark in captivity for a time period, release it. We did that several times. Got a huge bump in awareness about white sharks. It was a juvenile white shark, was a great tale because families could see it. It wasn't threatening. It was a baby shark. As a matter of fact, that's what it was. And with that, we used it as for a huge platform to raise awareness about the importance of shark protection. Attendance bounced up. We took the extra money we made. We invested it in white shark field research to understand what's going on with our white shark population that visits California. That study was published. It turned out it's a pretty small population. Advocacy groups then took that and petitioned for an Endangered Species Act listing for white sharks. This is an example of science to policy in action, and people, all of you, need to be involved to make that happen. And it's not hard to do, and it can happen at the local or the federal, at your country level, whatever the tools you have for animal protection. Well, and then a little bit on the sustainable seafood movement then, and Vancouver Aquarium's OceanWise programs, a big piece of this, building consumer action. And when you use your consumer information to select seafood, or you take your friends to a Vancouver Aquarium OceanWise restaurant, that's really making a difference. The more important thing you can do is talk to your friends about it, spread the word, and that spreading the word and including the media buzz that's come around this is turning the sustainable seafood movement and your personal action into a global change and improvement for how seafood is farmed and fished. I show here Seafood Watch, our app, Seafood Watch at the aquarium. We have the sustainability criteria and kind of the template for everyone else's outreach campaigns, including OceanWise. Big businesses are partnering with us and have made commitments. Companies like Target, Walmart. The U.S. imports 90% of its seafood. We have a big influence on the global market and what's going on with fish out there. That's weird. Fair trade. Human rights issue. That was very unexpected. I will say, whoever gave me this slide, though, the reason it popped up is we just are adding human rights into our sustainability criteria with a tool, because you've all read recently about the incredible issues with the seafood we buy here, right here in the U.S., where people are under, indentured service agreements. Little children are picking the crab that you buy in your freezer compartment at the grocery store, and we want to raise visibility to that and change. So again, with these awareness programs like Seafood Watch and the science, here you see a Seafood Watch report on just one species. Appropriately, I don't have my glasses, could be a salmon. And then moving forward to the policy action, where we now, you take that data and get get your leaders to do something about it. And now we have global action on stemming illegal unreported fishing. And last but not least, you can get your aquarium to be a voice. And in the US, we've just created a whole partnership of aquariums to use our voice. In this case, we were thanking President Obama for the new expanded marine protected area that was just announced. So in the end, in this slide, oops, the little girl on the right, she's in a North American aquarium. She's probably had kind of a privileged life. She's at a place like this or like Monterey. And she has the opportunity to learn, and hopefully will learn about the ocean impact on her life. But her everyday choices are also having a huge influence on the little boy on the left. He lives on the coast of West Africa, maybe got those fish. They fell off a big trawler as a bycatch, and he's selling them for a few pennies in his village or taking them home to his mom. We're all connected by the ocean and our global food system, and we need to think about that every day. And the actions we take here in North America can and are having a big influence. Thank you.
So we're going to ask the speakers to join us, please, at the front. So we're going to take questions from you, and we have a portable microphone, and we're going to ask anybody with a question to use it. We'll pass it to you because we are recording this for rebroadcast. But I'm going to use the speaker's prerogative and ask the first question. So I'm going to leave for the moment the question that everything's connected, because I think that's been amply demonstrated tonight. But we've heard that we don't know everything yet, so we need more information, and that suggests to me that more research is important and appropriate. There's not been much talk of the possibility of reversing some of the negative effects that have been talked about tonight. There has been talk about adapting to them and mitigating some of those impacts. So maybe if the panelists have thoughts on where the most effort is needed most quickly. In other words, is there a priority order and I want to be a little more sophisticated than just saying just research or figuring out how to reverse impacts or adapting or mitigating. I'd kind of like to break it down into the things we know that are impacting the oceans, and that would seem to be, from what we heard, human-caused. It's all human-caused, above natural variability, but indirectly through atmospheric changes and directly through things like pollution or plastics, and the outcome that has on ecosystems and then animals, whether it's singular animals like killer whales or ecosystems that produce sardines or produce salmon, because one of those impacts is back to the species that started it all, people. So if we could, that's a long-winded question, sorry. In other words, speak to, where are the linchpin points that we need to work on first and foremost?
Maybe I'll weigh in here if I can before we get into the climate change and the fishing aspects. But I didn't show them in my slides tonight, but I will on Thursday morning. I have 4 remarkable success stories in terms of ocean pollution. Everybody knows the story about DDT and eggshell thinning and fish-eating birds, top of the food chain, persistent bioaccumulative and toxic pesticide. When we discovered that DDT was at the root of this, and it was actually in U.S. Congress, a Republican congressman stood up and said, well, if it's doing that to seabirds, what's it doing to our women? So there was a quick regulation of DDT, and since the mid-1970s, and this is now worldwide, of course, the ban since 1970s or so, there's been a tenfold reduction in DDT concentrations in all sorts of species of fish-eating wildlife, top of the food chain. Another very good success story, right short on the heels there. PCBs were discovered in Antarctica and up in the Arctic wildlife, and very quickly they were banned in the Western world in the mid to late 1970s. We've seen a 4- to 8-fold decline in PCB concentrations in harbor seals here in British Columbia and Washington State. Dioxins and furans associated with pulp and paper mills, they're down, their emissions in British Columbia are down 95% since we discovered that commercial crab were becoming contaminated associated with adjacent pollution releases. So when there is discovery through scientific method of an accident or of a mistake, and we take prompt action, it can be regulated and enforced, or it can be through best practices or source control, or it can be you, the consumer, and the home operator. But when we understand the problem, we can point to some remarkable changes and some remarkable improvements in the health of the oceans, and I'll put it that way. We have much healthier top predators today than we did in the 1960s or 1970s, and that really speaks to almost every top predator in the ocean. And that's quite aside from the plastic story, but many good chemical stories there.
I guess answering the way John framed it, I think, is, what are the linchpin things we can do? And I would back up one level to Dr. Sylvia Earle, who Julie and I know well, and many of you probably have read her books and so on. And I remember Sylvia framing ocean issues as, what do we take out, being the fisheries issue, what do we put in, being the pollutant issues, and then the environmental, if you will, the acidification, temperature, and the larger questions. And so I'd like to start with that in terms of the three. And I think that in terms of simplifying it and conceptualizing this the way we can grasp the complexity of this ocean, obviously policies which help us regulate the fisheries, whether it be transferable fishing quotas or things like that, or catch limits and so on, is certainly the key. The pollutants, as you're talking about, there's a lot of different ways to look at how to limit what we put in the plastics and so on. And then on the climate part, which is the third leg of this, if you will, we've got to find a way to price carbon. And again, British Columbia, I think it's not pandering or just because we're here. The truth is, you have the best policy in the world at a large level that I'm aware of, which is the increasing and substantial carbon price, which then gets offset to other taxes. And so that's a great way to incentivize the province to reduce carbon, which is what's causing the warming and the acidification.
Yeah, there've been some really good success stories for coral reefs as well, and I think often it's involved a combination of effective management of the initial cause of the decline, but then often some intervention as well. Because, so for example, where I'm working at the moment is Kaneohe Bay on the windward side of Oahu in Hawaii, and it's a fantastic sort of case study for a reef that was really heavily polluted by sewage. I think sort of in the 1960s and maybe early 70s, and basically the entire reef, all the corals had been overgrown by fleshy seaweeds and macroalgae that outcompete the corals. And through science, people have said, look, if we reduce the sewage, if we manage it, then we can bring these reefs back. And that's what happened. But some of the algae was incredibly persistent, and the fish that would normally remove those algae weren't able to. So they've had other interventions where they've physically gone out and removed them, and they had a thing called a super sucker, which was basically a giant kind of underwater vacuum cleaner that sucked them out. And it turns out that you only really need to do that once to get rid of the most of the algae, and then the fish can sort of take care of what's left. So now Kaneohe Bay is an amazing place with very high coral cover. And the interesting thing is that those corals seem to be incredibly resistant now. They did suffer from thermal coral bleaching this year, but they're sort of recovering quite well. And I think some of these systems, once they've gone through these incredible perturbations, what comes back is actually quite tough, and a little bit more resilient and resistant than what was previously there.
And just adding to the previous comments about this, I think in terms of fisheries, in fact, decades of work, of research and evidence has shown that if we can manage the fisheries well, meaning that if we can reduce fishing effort and that it can be maintained as a sustainable level, then fish stocks recover. Often we know that combinations of different management measures, so including the use of marine protected areas with more effective management or regulations of fishing effort actually makes fisheries management more effective. And there are existing case studies that shows that with those in place, we actually can have a good, healthy fish stocks and ecosystem. And to do that, I think one of the more important or first things that one can do actually is the removal of harmful subsidies, because one of the main, at least at the global fisheries level, one of the main issues is overcapacity, meaning that we have too much fishing boats, the fishing boats are too big and too powerful to catch. But then a lot of the time, the reason why the fishing industry is able to build those boats is that because of the government are providing subsidies, so giving money to them so that they can build those boats, even though they cannot catch sufficient fish to compensate for the cost of that if the government doesn't pay subsidies. So if the government actually can reduce or eliminate those harmful subsidies, and maybe using those money to build social capacity and things like that to deal with some of the other issues that drive overcapacity, I think that would actually move a lot of ground in terms of advancing sustainable fisheries and sustainable ecosystem management.
Did you want to go first?
No, you had.
Okay. Well, I'll have to change the subject a bit because I don't know anything about fish. I guess in terms of things that seem to me are positive signs, the fact that we had an agreement in Paris to strengthen the ambition of climate change mitigation, to aim for or strive for limiting warming to 1.5 degrees rather than 2 degrees is at least a sign that that internationally governments are getting the message that this is an important issue that has to be dealt with, and that the way that has to be dealt with is by limiting emissions and ultimately getting global emissions to net zero. That's the only way that temperatures stabilize, is to get emissions to net zero. As long as you keep putting carbon dioxide into the atmosphere or other greenhouse gases into the atmosphere, even if it's at a slower rate or even if it's at a constant rate, they're still building up, and the imbalance that I talked about continues. So the only way to get temperature to stabilize is to have net zero emissions. And there is now an appreciation that that has to be done, and it has to be done quickly, because the longer that you delay, the more that cumulative total of carbon builds up in the atmosphere. And that, as I tried to point out, directly determines the ultimate temperature that the planet will get to. And I think that's, policymakers are now understanding that concept. Maybe they couldn't explain it very well to an audience, but at least conceptually it's being understood. And that's motivating action in part because it's now clear that every ton of carbon that you put into the atmosphere has a very long-term consequence. It's not something that just gets undone as soon as you stop emitting. So I think that, to me at least, it was a positive sign coming out of Paris, was that there is kind of renewed interest and enthusiasm in governments internationally to take even more aggressive action to mitigate climate change.
Let's see, am I talking climate or ocean? I guess first of all, just adding a few comments about the ocean side. Fishing, our extraction of fish is sort of our most basic human relation with the sea. I mean, we've been doing it since humans evolved, and the reason I think it's so important is that we have the solutions. We know what to do. We know what works, tried and true. We just need to make it happen. And you can say the same thing goes for climate. The difference is that we actually have a lot of really good things happening on the fisheries reform front that are yielding positive results, tangible positive results. I think the problem with climate is if we slow down the carbon emissions, I mean, is my life right now going to get better? Can I feed my family better next week? I mean, that's not going to happen. But with fisheries, yeah, I mean, it can happen, and it is happening. Even here on the West Coast, we have a super, big time tangible example. The whole groundfish fishery was closed for over a decade, and groundfish is, rockfish, lingcod, I mean, all the fish that hang out, that you get in the market that are, it's a whole assemblage. And the whole fishery was closed. It collapsed, or certain species collapsed. We laid off the fishing. They implemented a whole new fishing scheme, a quota-based scheme. People are back fishing, and fishermen are making money, and there are things on our plates in California that, I haven't seen for 10 years that used to be abundant. So the oceans are resilient. They can recover. Now, the problem is, when you're talking about ocean warming or acidification, all these marine protected areas or well-managed fisheries are still going to be taking a hit from those larger scale problems and changes that are happening. And that takes the political will. I would add, in terms of climate, along with the carbon tax, which is absolutely what needs to happen, and it's awesome. It's amazing that BC has actually done that. There are also some good things happening in terms of reducing emissions from deforestation in countries like Brazil and Indonesia, and the whole idea of realizing that intact forests have value, and we need to replant them and at least reduce deforestation. And certainly when forests are cleared, and that adds to emission when they're burned, countries are taking hold of that and they're making change, and there's economic value for them in doing that as well. So I think that's promising. Will it be enough in time? That's the challenge, but people know what to do.
So over to all of you to ask a question, hopefully not as weird a question as I asked, a little shorter maybe. Any questions or thoughts that people want to express, just raise your hand. Over there on the far side.
The question I had was about the cyclic pattern of the glaciations and the increase in sort of CO2 and temperature and then the sharp drop. I was wondering if any way that could be related to the amount of biomass on the planet, so that as things really get going, there's a lot of CO2, temperature increases, and then there's maybe a big die-off, because I was actually wondering about volcanism with the ice packs melting and glacial melting, like under Greenland. You've got that big rift that's opening up. If you get eruptions all over the planet and you get a lot of toxic gases released and you get a global cooling from, particles in the atmosphere and a huge event, you get a big die-off and then all the biota drops and your grass drop. I'm just wondering if that could be a cyclic pattern that happens.
Are you asking if the historic pattern of ice age cycles relates to that?
Yeah, if there could be a big biota increase, and then you've got all these sort of CO2 levels and temperature increases, and then you get a huge die-off because of volcanic eruptions worldwide and a big gas clouds and toxic.
You're throwing a lot of things in a bucket, and I understand that, and it's nice, and some creative thought. The glaciation cycle that's gone on for 3 million years is pretty well understood to relate that warming and cooling is because of a combination of 3 different planetary cycles of the tilt, the wobble, and the shape of the elliptical orbit around the sun, which becomes the simplest way to describe it as a giant summer and winter every 100,000 years. And while the biota has changed, and even when we've had a super volcano, it does a dent in the temperature, but the truth is, whether it be Pinatubo or any other big volcanic explosions, at this point the Earth systems absorb that pretty quickly. The ice age cycles were, as I say, for millions of years, and with the stability of the biosystem that we have, even though there's variations year to year, that giant glaciation cycle is driven by this solar cycle roughly every 100,000 years.
G'day. Just had a question about the corals. You're saying about, I guess, correct me if I've got the terminology wrong, but introducing more hardy corals to replace the ones that we've lost. Is there any thoughts on what might occur replacing corals that we've lost with different ones?
You're talking about different species, or?
Yeah, I know you just touched on it briefly, but yeah, introducing different species from ones that were there originally, I guess.
Yeah, I mean, this is very new, and nobody's really actually done this as a proper intervention. I mean, even coral restoration hasn't been done successfully on any meaningful scale yet. I mean, people transplant corals, or they put in artificial structures, but for the most part, the corals that get transplanted, they usually die again because the problem that caused the decline in the first place is still there. So it's a really, you know, we're at a very early stage with this. And the idea is that, you know, we're really like running out of time for corals because they've got so close to their sort of thermal limits that if we don't attempt to do some sort of assisted evolution or assisted adaptation, or at least build the tools and the techniques to do it that would allow us to do it if it's necessary. Now we won't be able to do it in the future. You know, the resistant genotypes might have gone. But there's various different approaches you could take. One could selectively breed resistant corals, so you could go out and identify some particular individuals. In the lab I work in now, they call them supercorals. So these are ones that have a whole load of resistant phenotypic traits that will allow them to survive through in future climates, and you could selectively breed those and then increase the frequency of those within a population. That would be one approach. You could also try hardening corals, so through epigenetics, which is where you stress an individual, and that actually has a genetic change on that individual, which can last for a long time. They can have a memory of that, and potentially those changes. This is like a Lamarckian type evolution. This is where a change that an individual experiences in its lifetime can be potentially passed on to its offspring, and this is something that is thought to occur in very long-lived organisms like corals and trees. And then the other thing which people have talked about is assisted migration, which is where we're taking corals from places like the Persian Gulf, organisms that live in very variable, very high temperature stress environments, and they've adapted already to those environments, and saying, right, okay, these are the corals of the future that we need to shift to other places. So people have talked about all this stuff, and they haven't done it yet. But we need to do some of the experiments now to look at what the implications are. One of them might be trade-offs. For example, if we breed an organism that is very thermally tolerant, it might be very weak in other ways. It might grow more slowly or produce fewer eggs, and then that particular individual would be less adapted during years when there's no thermal stress. So those are the kinds of things we need to know.
I have a quick question. World population's going up, fisheries are going down. Is aquaculture the answer?
Yeah, I think so. It's not a strict answer. It depends on the type of aquaculture that you are developing. So right now, if you look at the global aquaculture, a lot of it are not for food security purpose. It's for the global markets. There are lots of the developed countries, people are actually buying that. So if you look at it from the food security point of view, we may need to invest in developing aquaculture that are targeted, that provide fish that would benefit to people, that can be consumed by people who need the seafood for their nutrition, as well as in an environmental friendly way. That means that we are not farming high trophic level species that we need to feed fish to them. And then at the same time, we also need to be wary about or careful about the developments of aquaculture, where there may be trade-off with other development in terms of fisheries or in terms of how fisheries may respond to other drivers. So for example, when there is an expansions of developments of aquaculture, particularly those that are sold into the market, often the large production of cultures may drive down price of fish. And that may be good for consumer, but then for some of the coastal fishermen, that may not be that much of a good news, because the decrease in price, it may exacerbate, for example, the impacts from climate or from other aspects of drivers that decrease in fish catch, and thus with the decrease in price, it may also further exacerbate that impact. And we are seeing that, for example, with salmon, with the large expansions of the aquaculture of salmon. Salmon price in the market decrease, and some of the salmon fishermen are actually suffering from that as well. So I think it can be a solution, but I think it needs to be a carefully planned solution.
My view is aquaculture is here to stay. It's not going away. The amount of seafood that we have globally now from farms is, equals the wild caught fish, and so it's going to keep increasing as the wild caught is sort of flat or slightly decreasing. We can maybe get that to increase again, but aquaculture is doing this. So the question is, how can we do it in a way that's benign and provides protein and livelihoods for people? And just to mention, what I think some good news on that, the sustainable seafood NGOs working on this and the aquariums, we've been doing a lot of work on this whole matter of what would be a definition of sustainable aquaculture and how can we help all these aquaculture enterprises improve their practices. So they're actually, the Seafood Watch and similar programs rate aquaculture enterprises as to sustainability, but there's also going to be a third-party certification program called the Aquaculture Stewardship Council that at some point hopefully will end up with like a label, eco-label on the package. Now, you all have all kinds of beautiful fresh fish here. I doubt anyone here in the room would get near a piece of farmed salmon, but because this is a BC audience, I have to share Seafood Watch. When we were working on the farm salmon, because farm salmon is like a huge commodity and big deal in the U.S., of course, when we were working on the sustainability standards for farm salmon, and there were some salmon aquaculture enterprises that were about to get into the Seafood Watch. They were getting out of the Seafood Watch red and into the yellow, not in the green yet. They had improved their feed conversion ratios, and they had done a lot of improvements. And I got a call from like all the BC NGO advocates. They wanted me on the phone personally because they were so mad and worried that if salmon aquaculture, was rated to be less environmentally damaging, that, you would have all these salmon aquaculture, farms built on your coast, which you don't want. And I thought it was really a fascinating, I was kind of in a bind, and you can tell me if this is the right thing to say. All I said was, we're here to drive improvement because the salmon farming industry is huge and it's here, it's not going away globally. But it's up to every country if you want to see salmon farms on your piece of coast or not. So, you can choose to not have salmon farming wherever you don't want it. You have to get involved and lobby for it. But at the bigger scale, it's important to drive change, and they are making really a lot of improvements.
One more question. I saw a hand somewhere.
Hi, I'm sorry. My name is Vivian. I work at the aquarium with the membership department here. Each one of you represent a battle that's being fought for our oceans. And you're just a small proportion of what the oceans are actually facing. Every single one of the people in here are engaged members. We want to do something to help offset what you are all telling us, whether it's the loss of the oceans, whether it's climate change, whether it's pollution, whether it's overfishing. What I'm hoping is, if I could get from you, what would you recommend that we do and what we say to our friends and our families, to strangers out there? How can we promote this message so it becomes effective, that we can implement a change from the small scale that's in this room into a global change that we have seen that Dr. Ross has talked about on a global scale? How can we affect that change for each of the battles that you guys are fighting right now?
Gee, I'll take a quick stab at that. I think basically what we're talking about is the world around each of us. And for me, when I talk about ocean pollution, I'd say everyone in this room or at home has to ask two questions. When you're going shopping or when you're doing something and you've got a product, whether it's clothing, whether it's your automobile, whether it's stereo, whether it's batteries, whether it's a plastic bag, two questions. Where did it come from and where is it going? because you are a steward, you are a custodian of that product. Where is it going? Because once it's out of your house, is it going to landfill? Is it being headed to recycling? Is it recyclable, or is it only sort of 25% recyclable? Where is it coming from? Gets you to the source, gets you the regulations, gets you the best practices. 2 questions helps you inform yourself as your role and your responsibility. Most people don't know where their milk is coming from, where their cheese is coming from, where their cell phones are coming from, or the circuitry they're in. So 2 questions for each to become engaged in what I think is a very, very important part of the new era that we're in, and that's the power of the individual in a consumer society. For a long time, at least in Canada, we've looked up at good government, big government that's been there, and we've trusted it. I think the situation tends to be a little bit less so in the United States, but we've certainly seen a shift towards the individual taking responsibility for their actions and getting more informed, and also industry becoming more interested in best practices, green design, et cetera, et cetera. 2 questions. Where does it come from? Where is it going?
Everyone in this room, if you're involved with the Sustainable Seafood Program here at the aquarium, you are making global change. It's unbelievable. That would be a whole nother talk. For you to see the impact that's having, it's really quite remarkable. It's getting the attention. It's changing the whole industry in many parts of the world. It really is making a difference in these big business commitments by the big buyers. That's because of consumer choice and because of you voting with your wallet, talking to your fish counter person, demanding, more sustainable seafood. So keep that up. It's making a difference. On the climate issue, I guess I would just, say the big NGOs working on climate mitigation and all the analyses, the fact of the matter is policy change and business change is absolutely essential. And we all need to do as much as we can in our personal lives. But, in the end, for example, if we use less energy in our house, that's fine. But if our energy is produced from a coal-fired power plant, that's not going to move the ball as much as if we lobby our government to get in gear and, change their policy so you're not building any more coal-fired power plants. So I can't emphasize enough the importance of get involved with your NGOs, whoever's working on climate policy, get involved in that, and also from a local level. I mean, there are a lot of local and regional commitments that communities are making that are very exciting in terms of green energy and kind of building from the individual up to the next level to demonstrate how you can do it.
I'm going to jump in here because I think, one of the premises behind the changes in this organization is that the first thing we can do is even simpler. We can just talk about the oceans, right? If we're interested and if we talk about it, and governments respond to public discourse. There were 2 million Canadians talking at the water cooler, at the dining table, at parties about interesting things about the oceans and why they matter. Governments notice. They follow their public in terms of public interest. So even before we have to go lobby, if we can just grow the choir of people who are interested and actively talking about it. And of course, that takes some sensitivity. You don't want all your friends to walk across the street when they see you coming. So you have to go about it with. But the ocean and the freshwater environments of the world are so full of interesting stories and interesting connections that it doesn't take much to get most people interested. Thank you all for coming. Okay, thank you all. I should have said thanks to our panel, too.